Okay, so I wanted to do a quick Camtasia of a diagram that we talked about in class. So I'm not really sure where my original one went, but I just redrew it really quick for you guys, a little bit neater than what I did in class, so that hopefully you can see all the labels. And I'm just going to talk you through the circulation so that you guys can just watch a quick video, and hopefully it'll be easier. So everything on here is labeled. Hopefully you can read it. You have, again, your superior vena cava, and then down here is your inferior vena cava. It's the same vessel. It's just the blood that's returning from the upper body, like your head, is coming in through your superior vena cava. And then the deoxygenated blood that's coming from your body back to your heart through the inferior vena cava, like your lower body. That blood is going to dump into your right atrium. So you can see these arrows that I've drawn. This blood is going to go into your right atrium here, and it's going to fill. We're going to talk about the conduction system next, like what actually happens to create the movement of blood from your right atrium to your right ventricle. But for right now, all you need to know is the blood fills your right atrium, which again is this thin-walled cup that's really just designed to gather as much blood as it can. It's not very muscular. It's just sending blood through to your right ventricle, so it doesn't have to go very far. So the deoxygenated blood comes from your body, fills your right atrium, and then it's going to travel through. This is your tricuspid valve, and your tricuspid valve is your right-sided AV valve. And AV just stands for atrioventricular, so it's the separation between your atrium and your ventricle. And although my illustration does not show it in its complexity, it's anchored here to the walls of the heart, and it's designed to only open one way because it wants to allow blood to come in from your right atrium into your right ventricle. It does not want blood to go the other way. It does not ever want what they would consider a backflow of blood. So you never want blood to come from your right ventricle and go back into your right atrium. This is designed to only flow one way. So you go from your right atrium through your tricuspid valve into your right ventricle. Now your right ventricle is going to be more muscular than your right atrium. It's still not as muscular as the left side of your heart, which we'll talk about here in a second, but your right ventricle is designed to be muscular enough that it ejects blood through your pulmonary valve, which is your first semilunar valve, and they just call it the semilunar valve because it has these three kind of cusps that come together that are essentially like crescent moon shaped. So your right ventricle sends deoxygenated blood through your pulmonary semilunar valve into your pulmonary artery. And I talked about this in class. Your pulmonary circulation starts here at your pulmonary valve. Okay, so this is where your pulmonary circulation starts. Your pulmonary circulation is just the circulation that involves your heart and your lungs, and it's the opposite of our systemic circulation. So it starts at your pulmonary valve and your pulmonary artery, and now you're in pulmonary circulation. So the deoxygenated blood is going to go through your pulmonary artery away from the heart and into the lungs. So you go from the pulmonary artery into a smaller arteriole, which is then going to go even smaller into a capillary, which is that exchange vessel. It's going to be surrounding an alveoli, and then hopefully you have a properly functioning alveoli that's going to participate in gas exchange well. It's going to pick up oxygen, drop off CO2, and then now you have this red oxygenated blood coming back to the heart through a vein. So it starts with the venule, which is just a small vein, and it's going to go to larger veins, and then it's going to actually get back into the heart through these pulmonary veins on both sides, and they're labeled over here as well. That is going to dump oxygenated blood into your left atrium, which I have labeled here, your left atrium. When your left atrium is full, and then when systole starts, which we'll talk about when we get into the conduction system, but basically that blood is going to flow through your mitral valve, and again, it just wants to flow the one way, okay? It does not want to go the other way, so just one way. So that blood's going to flow from your left atrium into your left ventricle. Now your left ventricle is your workhorse of your heart. This is where 2/3 of your muscle mass lie. Okay, that's why most of your heart lies to the left side. If you're looking at that AP view on that chest x-ray, I highlight how you can tell a lot of that heart is to the left. Your left ventricle is very muscular. And the reason why is it's pushing blood, it's ejecting blood out into your body, and try to imagine all the different positions that your body has gotten into. If you raise your hands up in the air, how much movement your body is capable of. Your left ventricle is essentially what's pumping blood to all of those potential body positions, all of those different areas of your like your tissues, your fingers, your organs, everything. It's responsible for meeting their metabolic needs. So it has to be a higher pressure system, it has to be a stronger system, and it has to be able to have lots of tools to fluctuate based on activity. So your left ventricle is really the biggest portion of your heart. It's really the workhorse of your heart. So when the left ventricle gets filled with blood, it's then going to eject, the left ventricle is going to eject blood through your aortic valve into your aortic artery. You have these little notches that are going to send that oxygenated blood up to your head. And then down here, you have your descending aortic artery, and it's a very large vessel, huge. And that's going to send blood out to your body, to your lower body. So that's going to send the oxygenated blood out to your body. Out in your body, we'll talk about the systemic circulation kind of in the same way we did with the pulmonary on a different diagram, but it's going to go out through your body, participate in gas exchange, and when it has dropped off its oxygen and picked up its CO2, it's now going to come back to your heart through the inferior and superior vena cava. What gets tricky when you're talking about like the systemic circulation, the pulmonary circulation, is it's a loop, right? So they all affect one another. They all kind of are interrelated. You can't really fully separate one out from another one because it's a circle. That being said, in the same way that I isolated the circulation here in the lungs, I'll do the same thing for the systemic circulation so you guys can follow it through to like kind of that micro circulation, they call it, where you get down to that capillary stage. But this is kind of that overarching circulation. You can see how it leaves the heart, you can see how it comes back to the heart, and you can see where the gas exchange is occurring. So I just wanted to do a quicker, shorter video of that so that you guys can follow that through. And again, going back to that heart anatomy PowerPoint, really know your structures of your heart, memorize them. You are going to be responsible for them. When we start to get into the concepts of hemodynamics, if you don't have the order of circulation memorized and you don't have these structures memorized, it's going to be really difficult to understand the concepts of hemodynamics that we're going to get into and like the patient case scenarios and how it's going to be applied. So definitely take the time to do that.